Welcome, flip clock fans. These are images of a little Seth Thomas flip clock from a recent eBay listing. It caught my eye because I like plain flip clocks, that is, clocks that just tell time, no alarm, no radio. It says it's a model 0858-000. I was able to get this little guy in Flip Clock Fan Studios and was surprised by several things. First of all, it's not a little guy. This is a Seth Thomas cube clock, and while the height is close, you can see a huge difference in the size of the digits. When comparing this clock to this Copal 227, you can really appreciate the size of this Seth Thomas catalog number 858. Now the second obvious thing is that this is a ticking flip clock, just like this Seth Thomas rolling wheel clock, and also like this Seth Thomas wall clock. Not only that, I learned that the clockworks for all three of these clocks are the same. Also, the mechanism in this wall clock is essentially exactly the same except for the position of the battery holder. The mechanisms are basically interchangeable. What I'd like to do is get inside this flip clock and go over how this flip clock works. It really is unusual in the world of flip clocks, not only because, frankly, it's noisy, but because the mechanism is, well, almost a hybrid. There you see the catalog number 858 and the model number. These are not always the same in Seth Thomas clocks. It reads a Tally Industries company, so we know this clock was made after 1970. It was 1970 when Tally Industries took over General Time Corporation, which was the holding company for Seth Thomas and West clocks. General Time is in fact stamped on the clockworks. The clock uses one C-cell battery. The face is held on by two screws. Just like the wall clock, the mechanism is held in place by four machine screws. The whole clock was made in Japan, even the clockworks, although like I mentioned, it's stamped General Time, who likely held the patent. The clock just slides out. It seems to be a nicely constructed wooden case here. There seems to be a lot going on here when you first get a look at this driving mechanism. I've already removed an extension post that was for adjusting the speed of the clock. You can't get the case off until you do that. Just one screw holds this plastic cover in place. Right away, you see an unusual movement going on when the clock flips. The time is measured out by a mechanical clock. It's got a balance wheel, an escapement, and a mainspring. I'll show you the spring in a minute. So as many of you know, the gears are releasing the tension in the mainspring as metered out by the escapement, the tick-tock of the clock. If you watch to the left, you'll see a rapid movement associated with the clock flipping. That causes the characteristic sound of these clocks, ticking and a whirl every minute when the clock flips. I run the wall clock daily. I'm used to this sound. Let's try to review what's going on here. During the rapid movement, this rocker arm moves, positioning this end, which happens to hold a magnet, next to what is known as a reed switch. This causes two metal blades located inside the glass tube of the reed switch to come into contact, completing an electrical circuit. The whole point of the mechanical clockworks is to control when this happens, which is obviously every minute. A key component of this situation is this freely rotating triangular-shaped plate. It has three rod extensions that take turns interacting with the magnet holding rocker arm. The plastic wheel behind the black plate and a protrusion on the mainspring control the position of the rods, which results in turning the DC motor on or off. At this point, you can see two of the rods and the coiled spring. Only the top rod is contacting the rocker arm at this time. It will gradually turn with the spring and then suddenly release the rocker arm, allowing it to move, the arm being spring-assisted to move once released. If you watch here, what has happened is the mainspring protrusion has just contacted one of the rods and is moving it forward. Prior to this, the rods and the black triangle that they are attached to were stationary. You can see it slowly moving with the ticking of the clock. It's hard to see here, but the rod that is towards the back is about to slip off the rocker arm. Three things just happened. The rocker arm moved forward, causing the magnet to contact the reed switch, completing the circuit to the electric motor. The motor simultaneously advanced the flip clock and rewound the mainspring. As the spring was wound, the plastic wheel behind the black triangle rotates the triangle and its rods, moving one of the rods in a position that moves the rocker arm magnet away from the reed switch, ending the current to the motor. Let's walk through it. The reed switch completes the circuit here when activated, turning the motor on, causing the worm gear to rotate. The gear will rotate for as long as the magnet is near the reed switch. When it rotates, it turns this wheel, which rotates this rod and gear, advancing the clock 1 minute. At the same time, this wheel attached to the spring is rotated, winding the spring. That is accomplished through this gear. Once the motor stops, the worm gear acts as a brake, holding the spring in place on the right side. On the left side, the spring is allowed to slowly unwind by the mechanical clock gear train, moving this brass gear clockwise. The purpose of the spring, besides running the mechanical clock, is to move the 3 rod extensions. You can see the protrusion from the spring lifting a rod. Once the rod slips off the rocker arm moves the magnet to the reed switch. That's the protrusion that moved the rods. It's on its way to pick up a rod to rotate the rod assembly. The rotation of the rods causes the rod next in line to move the rocker arm back to its starting position to ready for the next minute drop. There's a lot going on all at once, but once you follow it through, it all makes sense. Maybe it's crazy, but I really like to watch this work and the sound doesn't bother me. This rod here is basically doing nothing at this point. Now it's hard to see, but there is a rod that is getting ready to release the rocker arm. Right there. And it starts all over again. I have no idea how to name this clock mechanism. Maybe we can call it the General Time Self-Winding Mechanical Clock Switch DC Motor-Driven Clock Works, or GTSWM-CSDCMDCW for short. To me, these ticking flip clocks have character and charm. They're retro to the extreme as far as flip clocks go. Sure, this is not a great way to flip a clock, but it sure is fascinating. To me, anyway. The Seth Thomas Model 0858000. Thanks for taking the time.